Hello, and welcome to the Kinepict Knowledge-Based Podcast. I'm Szabolcs Osvet.
And I am Christian Szigeti.
We are the CEOs and co-founders here at Kinepict, and every month we are going to be welcoming guests from within lots of different aspects of medicine to talk with us about best practices and new innovations in the industry.
Today we are welcoming Dr. János Kis from Kinepict, who is a CSO. Hello, János, and welcome.
Hello, everybody. Thank you for the opportunity to be here, and I would like to greet our listeners.
Please tell our listeners what you are going to talk with us about today.
Okay, so today I would like to tell you some information on our different digital variance angiography algorithms, and I would like to present you some data as well, clinical data from our clinical investigations, which demonstrate the benefits of our algorithms. Namely, I would like to present two algorithms, the DVA1, which was the traditional original algorithm, and the DVA2, which is a specially designed and newly developed algorithm. Details are later.
It's very good, but I don't think so the listener know what is the DVA1 and DVA2. The DVA1 technology is based on a basic patented Kinepict algorithm. In many clinical areas, this has worked very well, but we have started developing a new algorithm as called later DVA2. What was the clinical need to develop the more algorithm?
Well, actually, yes, as you mentioned, the original traditional algorithm, the DVA, which was called later DVA1, performed very well in different areas and different settings, as we investigated in the lower limb angiography, also in the abdominal settings, and also in uroangiography. But we realized that under certain conditions, even this algorithm, although performs much better than the DSA, the gold standard digital subtraction angiography algorithm, even in this case, it has some problems, and the justification or the judgment of the image and the diagnostic evaluation of the images sometimes is, even under these conditions, is difficult. So we decided that probably with some modifications of the original algorithm, we could further improve the performance of digital variance angiography. And that's why we have started to develop this new algorithm, which we called later DVA2. Actually, what we realized was the first experience. You know, our first clinical trials were mainly in the lower limb, and the interventional radiologists who used our algorithm on the DVA1 experienced some difficulties to evaluate angiograms which were taken or acquired under difficult conditions. For example, you know, one of the major benefits of the DVA technology is the dose management, which means that the quality reserve or the excess quality of the DVA angiograms allows the reduction of radiation dose or contrast agent amount. However, under these conditions, the image or the acquired image is not as good in quality as under normal conditions when we obtain the image with a full dose protocol. And also we have tested our DVA technology in carbon dioxide assisted angiography. And we also experienced some difficulties, especially when we tried to evaluate the angiograms, which were taken in a lower part of the lower limb, the popliteal and the talocrural regions. And that was the need that generated the need to develop something which probably could further improve performance of DVA. And finally, our algorithm developers, found a solution for this and developed this new technology called DVA2, which is basically similar to the DVA1 technology, but uses different algorithms to reduce the signal, to reduce the noise on the images, and also, which is a very frequent problem in lower limb angiography, is that the bones and the shadow of the bones cause artifacts which make the evaluation of the blood vessel, the condition of the blood vessels difficult. So this special algorithm which we decided to develop aimed at to reduce the artifacts in the lower limb and also to improve the signal to noise ratio. And especially, which was a special need, we aimed at to improve the visualization of small vessels. In the popliteal and especially in the talocrural region, there are many small vessels of which the condition of which should be clearly visualized and diagnosed by the interventional radiologist. And for this purpose, we developed finally this DVA2 technology. I wouldn't go into the mathematical details. The most important is that the DVA2 reprocesses the images.
Okay, and what are the big mathematical and algorithmical difference between the DVA1 and DVA2?
Well, I think I wouldn't like to go into the fine details, but what is the main difference is that DVA1 is based on the standard deviation calculation. So it means that we take every pixels from a series, from an acquisition, and we calculate the standard deviation for each pixel, which means that we receive a kind of, that's why we call it digital variance angiography. Now, in the case of DVA2, we use a similar basis, and we use actually the DVA1 image for the basis, but after that we use a more complicated algorithm which calculates not only the single pixel images, but takes into consideration the images around the single pixel, which means that we can get a kind of smooth picture or image. And also we can apply different filters, noise filters. The user can select between different filters, median or mean filters, or he can select an image without the filter. So it's optional and depends on the taste of the user, who can compare different types of images. And the final result of all of these additional manipulations are that the image will be much better in the signal in terms of signal to noise or contrast to noise ratio, and also the unwanted bone artifacts might be minimized. Blood vessels are visualized much better. So that was the major reason, and that was the aim. And we believe that finally DVA2 accomplished this task and performs better under certain conditions than DVA1.
Based on the clinical result, what do you think? Which of the region there the DVA2 is better than the DVA1?
Well, actually, we made a lot of comparative studies to investigate the usefulness of DVA2 over DVA1. And what we realized was that actually when we use it in the abdominal region, for example, in embolization settings, DVA1 performs much better than DVA2. So apparently, because of the anatomical conditions, because of the presence of the intestinal gases and the bowel movements, probably here the DVA2 algorithm is not appropriate for use. On the other hand, when we investigated the lower limb, we realized that even in the lower limb, there are some limitations for the use. Very recently, we have published a paper with Professor Manken's group. Actually, this is a very good group from Marburg, the Gießen University Marburg. And actually, we have investigated the use, and we have compared the use of DVA1 and DVA2 in selective lower limb interventions. I would like to emphasize this selectivity because it means that the catheter is usually much closer to the lesion, usually in the femoral artery close to the lesion site, which means that the quality of the image is much better than in compared to the diagnostic angiography, lower limb angiography. In contrast to the selective angiography, when we use diagnostic lower limb angiography, the end of the catheter is above, typically is above the aortic bifurcation, which means that the contrast agent has to pass much longer sections of the blood vessels, and the bolus of the contrast agent bolus will be diluted, and therefore the intensity of the contrast agent will be lower compared to the selective angiography, where the end of the catheter is very close to the lesion site, and the bolus will be more compact when visualizes the lesion artery segments. So what we observed that when we compared the DVA1 and DVA2 in this selective angiography setting, actually DVA1 and DVA2 performed very similarly. There was no big difference between them. So there were no advantages of DVA2 under these settings. However, I have to emphasize that, as I mentioned, DVA2 was specifically developed for conditions where the visualization or the conditions are difficult for the visualization of blood vessels. Typical condition, for example, when you use this diagnostic angiography, when the contrast agent is diluted, especially below the knee, and also in case of carbon dioxide assisted angiography, where the quality of the images is generally weaker or lower than compared to the iodinated contrast media assisted angiography. We finally found that although under normal conditions, DVA1 and DVA2 performs very similarly, when we have these extreme situations like the dose management studies, DVA2 performs better than DVA1. So we have just recently completed a large clinical study, large-scale clinical study on radiation dose reduction in patients with lower limb diagnostic angiography. And what we found was that actually under reduced conditions, when the radiation dose was reduced by 70%, the DVA1 algorithm was equal in quality with the full dose DSA algorithm, which means that the DVA1 performed perfectly and provided identical image quality as DSA, full dose DSA. On the other hand, when we compared the DVA2 angiograms, we realized, or the results show, that the DVA2 has better image quality, provides better image quality, and what is more important, better image quality than DVA1 and better image quality than DSA, full dose DSA. And when we studied the different regions, we found that the lower the region, the bigger the difference for DVA2, or the bigger the advantage for DVA2. So it means that in the popliteal regions, and especially in the talocrural region, DVA2 performed much better than DVA1. Actually, about 70% of the images were received higher quality score for DVA2 than DVA1, and only 20% of the DVA1 images was better than DVA2. 10% was identical.
It is very exciting. What does it mean?
Okay, so actually, and I would like to emphasize, because this is the take-home message between the DVA1 and DVA2, that we have developed this new technology, DVA2, and the available clinical data show that this new algorithm and new technology is especially advantageous under extremely bad conditions. I mean the bad when the visualization of the blood vessels is difficult. For example, it's a typical situation when we use dose management. If you reduce the radiation dose, of course, the image quality will be lower. And under these reused conditions, or if we reduce the contrast agent, the result is the same because we use less contrast, so the image quality is weaker again. So under these conditions, when there is an extreme situation for the angiography conditions or acquisitions, DVA2 might be much better than DVA1, and we recommend the use of this new algorithm, especially for these conditions.
If I understand correctly, during the intervention, usually use iodinated or CO2 as contrast media, but below the knee, the CO2 is not giving enough image quality. Could the DVA2 helps in these cases to change into iodine-free protocols?
Well, exactly. That is one of the major advantages of DVA2, because our preliminary clinical data show that if we use the DVA2 algorithm or processing method for lower limb angiography acquired under conditions where CO2 was used as a contrast agent, the image quality is dramatically improved. So it means that the DVA2 is also very suitable for lower limb interventions when CO2 is used as a contrast agent, and especially the below the knee regions, where typically the carbon dioxide assisted angiograms are very, the normal DSA, in DSA mode are very poor, have a very poor quality. So yes, the answer is yes. This is another situation, the carbon dioxide assisted lower limb angiography below the knee, where the imaging conditions are very difficult. And under these conditions, as I mentioned before, DVA2 performs very well.
How will be available for the end user, this special algorithm?
At the moment, the current release, which is currently 5.1, but very soon we will release the 5.2 version. DVA2 is available for everybody and for every applications. But as I mentioned, what we saw was that the advantage of DVA2 can be observed mainly in the lower limb interventions, and especially in the below the knee regions, the talocrural, popliteal talocrural regions. And because of this, we thought that probably we will develop a special module for the Kinepict software, which is tailored and designed for, especially for these very important below the knee interventions and lower limb interventions. And we will specifically incorporate to this version the DVA2 technology. And probably we will not include in all other versions. Of course, it requires some further planning, but I have to mention that, of course, if you calculate more images, it takes more time. So in certain areas where the DVA2 image is not beneficial, it makes no sense to dedicate time for the calculation of DVA2. But it depends on the developmental plans. But it is obvious that if we develop a specific tool, a specific version of the software which is dedicated for the lower limb interventions, and especially for the below the knee interventions, and probably additionally the below the knee interventions with carbon dioxide angiography, then I think it's worth to incorporate the DVA2 and use it because it has major benefits and advantages compared to the DVA1 method. So in the future, I think you can expect a special below the knee modules or a version of the software which is tailored for this purpose.
Thank you to all our listeners for joining us today. And a big thank you to János from Kinepict for sharing your insight and wisdom with us. If anyone has any questions, throw or comment about the things we have discussed in today's podcast, be sure to get in touch with us. Looking forward to catching you all next time when we welcome another inspiration guest to the Kinepict Knowledge Based Podcast. Bye.
Bye-bye, everybody.